Shall we begin?
Okay, hello guys. So we're moving on. We're still on this topic of stoichiometry, but today we're looking at voluminous relationships in gaseous reactions. Now, it's just accumulation of everything we've done thus far. The key thing with stoichiometry, and I cannot emphasize this enough, is find the mole. Now, you guys have heard me say in my classroom, molum. If you can find the mole, you can determine anything using the formula sheet and your calculator about any other aspects of your chemical reaction. So what do you need to know? You need to know how to find the mole. How can you find the mole? You look at what they give you. They'll give you enough information to find the mole of at least one of your reactants or one of your products. And if you can do that, then you can go from there to find out anything else of any of the other reactants or products. That's it. How cool is that? All right. So, volume relationship and gaseous reactions. Now, the key thing also here to remember is, how do I know it's a gas? Ooh, sorry. How do I know it's a gas? Well, I look at my chemical reaction and there's like an annotation at the bottom of the compound in little brackets, and that will have a very definite G. And if you see that G, you know it is a gas. And if it is a gas, you can use one of your gas formulas, whether it is the ratio formula, whether it is the formula of STP, the fact that 1 mole of any gas at standard temperature and pressure occupies a volume of 22,4 cubic decimeters. All right, so those are the two formulas to be looking out for when you are working with gases. Okay, now this doesn't mean that all of your compounds in your chemical reaction needs to be gases. Right, now let's look at an example. Ammonium nitrate is used as an explosive in mining. The following reaction occurs when ammonium nitrate is heated. So there we have our ammonium nitrate, and when it's heated, it produces nitrogen gas, water vapor, and oxygen gas. Now it continues and says if 750 grams of ammonium nitrate is used, what volume of oxygen gas would we expect to produce at STP? So we write down our balanced chemical equation, and they give us the mass of our ammonium nitrate, which is 750 grams. We calculate our molar mass, and that is going to equal 80 grams per mole. And then we calculate our mole using our formula, which gives us 9,38 mole. Now they want us to find the volume of our oxygen gas. So if we look at the ratio of ammonium nitrate to oxygen, we'll see that it is 2 to 1. So if we have 9,38 mole of ammonium nitrate, how much mole of oxygen do we have? And that is equal to 4,69 mole. Now we want to determine the volume using our formula, and we substitute our values into our STP formula, and that gives us 105,056, and to round off our 0.56, that's going to give us 105,06 cubic decimeters. All right, our next example says sodium azide is sometimes used in airbags. When triggered, it has the following reaction. So they give us the balanced chemical equation. Sodium azide gives sodium as a solid and nitrogen gas. Now they continue to say that if 55 grams of sodium azide is used, what volume of nitrogen gas would we expect to produce? So we write down our balanced chemical equation, and they give us the mass of the sodium azide as 55 grams. Then we determine our molar mass as 65 grams per mole. We substitute those values into our mole equation and get 0,85 mole of sodium azide. Now we want to determine the nitrogen gas, the volume of the nitrogen gas. So the ratio between the two is 2 to 3. So if we have 0,85 mole of sodium azide, then what is the mole of nitrogen produced? And that is then equal to 1,275 mole. We want to find the volume of the nitrogen gas. So we use our STP formula. We substitute our values into it. Change our subject. And then that gives us a volume of 28,56 cubic decimeters. Now do exercise 8-8.